Welcome back everyone. Now we are going to study about the 1 degree amine with nitrous acid. So as you can see the reaction is quite simple, but there is something happening in between that we are going to study after learning the very basics of this reaction. So let's begin. So as the basic starts, this is 1 degree amine as you can see, so surely it will might not work on 2 degree and 3 degree that you can guess from now. And this is our nitrous acid. So this is our acid and we are using HCl, which itself is a strong acid, and NaNO2 that I'm going to tell you in a while. So what is happening here? Well, very simple thing. N2Cl. Well, how you can guess it up? You can guess it up that these two things are actually reacting, but also HCl is taking part in this reaction. So don't assume it as catalyst. This is taking part. That's why Cl came. Otherwise, there is no trace of the Cl in these two things. Okay. So N2Cl, and where this N came from? Well, I'm going to tell you the entire thing one by one. So let's make all the possible combination and try what I told you before. So for this one, we are trying every possible combination that I have missed here. Well, why I missed here? Well, that's intentional because in all the book it is being missed out so that we can think for ourselves, or sometimes just to make the things easy. Like if you see this one and if you believe that this will going to form anyway, you just have to add water, and after reacting to water, R will get water will get break down into H and OH. So OH will going to come up with R. We will going to have H and Cl together, which will going to form HCl. So the only possible combination is N2, which is nitrogen. That itself is stable as it is nitrogen gas. So that simple it is. But where this came from is our question. So let's start our pondering point here, my dear. So let's begin and learn something. Be on the mission. So wear your glasses, sit back, and let's begin learning. Okay, so let's start this one. So what is actually happening? If you see all these things, these all the things are reacting. So first of all, let's remove what actually came already. So R came, N2 came, and Cl came that we are using here, right? So what we can cut from here? Cl can be cut it down, one and here, one and here, and R from here. So this is done. What next? The next thing that we can do is we have S2, we have H, we have N, and all such things as you can see. So if you notice, this water is actually not given by us. This is going to come itself. Yes, itself. How? Look at this very carefully. We have 3H or 1 4H. So 4 hydrogen. And how many oxygen we have here? 2 oxygens. So 2 oxygens. And what we do require? We require H2O. And if you double it, it's 4H and 2 O's. So we have 2 times H2O. So this H2O came from nowhere. It itself is forming the reaction that we are using it again. That is what I was talking about. The intermediate products can form and we will not even know that it's important in the product. It formed and it broke down because other products are not that stable. Like in our case, this itself is not stable. As I have mentioned, the plus and minus charges also, as you can see in this one. So what is left? V hydrogen is gone, S2 is gone, H is gone, and all the O is gone. Now let's see what is left. So Na is left here, O2 is left here, as we have just used 2O, So if you write the things as so let me change the color so that you can relate the things quite easily. So mm, let's use green color for this one. So O2 is remain from here, and A is remain, and what else we have here? We have N that remained here. Actually no, N is already covered. I just forgot to cut it. So, because this is N2 as you can see. So these two things actually remained. So if you even try to form something out of it, you have to do something like this: Na2O. If you double it, nitrogen will going to increase. This is the problem. This is the problem that we face every single time we try to write the reaction of the side products. That's why we generally ignore it. That's why we ignore intermediate products, because this itself is not stable. So it's difficult to understand that what its is role. But the role is actually that we provide something externally again, and then it will again going to react with the next molecule of RNS2. So that's why it is said that catalyst can react again and again and again without getting lost in the reaction. So in this reaction, if you see the catalyst as catalyst something, so it is sodium and oxygen. So these two act as catalyst. Now the things are getting really interesting, and that is the reason we leave every time the side product and the intermediate product. Well, I repeated the line two times. So now I think you have got my point and you have learned this reaction either. So this is unstable, and because of the instability, the alcohol is formed, which is ROH, nitrogen gas is formed, and HCl is formed, because this is the only possibility we have here. So that is for this one. We're going to learn the next reaction in the next video. So stick with me, stay tuned. God bless.